All right, how are you? Hope that you're doing well. So in this video, we're going to be looking into a probability exam question video. All right. Now, it's question 7, starting off with the first question. They said, okay, we are given two events, event A and event B, and it is given that the probability, so they gave us the probability of event A, and they also gave us the probability of event B, and they gave us the probability of event A or B not happening. So the first calculation is that we need to calculate the probability of A or B. Now remember your probability formula. So the probability of A or B, right, is equals to the probability of event A plus the probability of event B minus the probability of A and B. So the other probability for event A or B is that when you take the probability of event A or event B plus the probability of event A or B not happening, this should be equals to 1, right? So basically, this should be equals to 1. So now, making use of these two formulas, we need to try and calculate the probability of A or B, one of the two formulas. So here, as you can see, the information that I have, it only allows me to use this formula right over here, right? So now, making use of the formula, right? So what is my probability of A or B? This is what I'm looking for. I'm looking for probability of A or B. And I'm going to add it to my probability of A or B not happening is 0.05. And as a result, this is equals to 1. So the probability of A or B happening, it will be equals to the 1 minus 0.05. And as a result, my probability of A or B, punching that into your calculator, 1 minus 0.05, it should be equals to 0.95. So this is 0. Now, proceeding to the next question, they want to know that if these two events, event A or B, would they be mutually exclusive? Now, remember, when two events are mutually exclusive, if I were to draw a Venn diagram like this, they're gonna be like that. So this would be event A and this would be event B. So they have nothing in common. These are mutually exclusive events. And what do you know about mutually exclusive events? Is that the probability of A and B for these events, it's always equals to 0, right? So now, taking that into consideration, right, I want you to make note of this. We're going to try and use this formula to try and answer the following question to know whether these two events are mutually exclusive or not. And every time, whenever you have a question relating to mutually exclusive, this is the formula I expect you to go about using. So you need to use a probability of A or B, and this is equals to the probability of A plus the probability of event B minus the probability of A and B. But remember what we said with regards to mutually exclusive events, their probability of A and B is always equals to 0. So basically, if we could prove that the probability of A or B we have just calculated, it would be equals to the probability of A plus the probability of B. So if these two are equal to one another, therefore the two events would be mutually exclusive. Right. So our probability of A or B, we calculated it is 0.95. Now, when I add my probability of A and B, let me just add that. So my probability of A, how much is it? It's 0.25. And probability of B is 0.89. And now, when I add these two, 0.25 plus 0.89, both of them, their probabilities is equals to 1.14. Now, can you see that this 1.14 is not equals to our probability of A or B, which is 0.95? Right? Therefore, these two events would not be mutually exclusive, meaning that the two events, they are mutually inclusive, right? So to answer this question, you would say, okay, the two events are not mutually exclusive. Why is that? It is because the probability of A or B, it is not equals to the probability of A added to the probability of B. Now, taking that into consideration, let us answer the preceding question. So I'm trying to draw the two events. So this would be the first event. This would represent the second event. So this is event B, and that is event A. Right, because we have just proved that these events are not mutually exclusive, meaning that they are mutually inclusive and they have something in common. Now, let me write the information I know so far. So you know that in order for me to get the probability of A, right? So this probability of A, which is 0.25. So what I needed to do, I needed to take the probability here and add it to the probability there, right? So let me represent my probability. So let me just do this. So let's represent this probability of A and B as X, which is what we are looking for. Now, to get my probability of A, right? So, okay, the probability of A or B not happening is 0.05. So this is my sample space. I'm gonna write it here. Now I need to calculate the probability of A and B. So remember when you take the probability of A, right? So the probability of A only plus the probability of B only plus our probability of A and B plus our sample space. Everything inside this diagram, the Venn diagram that we have, should equate to 1, right? So everything here, it should be equals to 1. Now, how do you go about finding the probability of A? Remember, to find the probability of this event A as a whole, we would have taken the probability inside A, added it to X. But now we want the probability of A only, which is the value that must be here, right? So in order to do that, we would need to take the 0.25, which is the probability of A, minus the probability of A and B, right? Therefore, we would get the probability of A only. Plus, same applies with your probability of B. You would need to do the same. So you would need to take the 0.89, because it's for everything, minus the probability of A and B, which is indicated with the letter X. And as I've said, we need to add our probability of A and B, which is X, plus 0.05, and all of this should be equals to 1. Now, let us simplify this, right? So if I were to simplify it, this negative X is going to cancel out with this positive X right over here. So as a result, I would be left with 0.25 plus 0.89. So now I'm grouping like terms together. And I am left with, so it's 0.25, right? Plus 0.89, and I still have this 0.05. And I am left with this negative X. And all of this, as I've said, it should be equals to 1. So what's left is that I'm going to take this X to the other side, and I'm going to take this 1 to this side, right? And therefore, I would find the value of my X. So basically, my X is equals to 0.025 plus 0.89 plus 0.05 subtracted by 1, right? Now let me just punch that into my calculator. 0.025 plus 0.89 plus 0.05 minus 1. And your X value, it should be equals to 0.19. And as we said, this 0.19, it is the probability of A and B, right? Always remember this formula, or always remember that everything inside your Venn diagram should always be equals to 1. Your probability of A only, your probability of B only, plus the probability of A and B, plus your sample space, it should be equals to 1. So now we have calculated the probability of A and B. I'm just going to substitute it onto my Venn diagram right over there. And it's 0.19. Now, the preceding question was the probability of B only. Now, remember, I said the probability of B only, it will be when we take the 0.89 and minus the probability of A and B, which is 0.19, right? And as a result, 0.89 minus 0.19, it should be equals to 0.7, right? Because why? To find the probability of B, we would take this 0.7 and we would add it to this 0.19. And as a result, we would get the probability of B as a whole, right? Now, B only, it is 0.7, right? And if I were to do the same to find the probability of A, I would need to take the 0.25 and minus 0.19. And as a result, it would be 0.6, right? This would be 0.06 rather, 0.06, right? And to test whether this is correct, right, you could just add the probabilities inside your Venn diagram. 0.06 plus 0.19 plus 0.7 plus 0.05, and everything inside this Venn diagram should be equals to 1, right? Now let us move on to the next question. Now the next question says, okay, a small town of 1,500 people. So they gave us the total population as 1,500 people, and they said they have two main banks. So the first bank is Ed Savings, right? So they have Ed Savings as well as Multiplier Bank, right? So multiplier bank. Right. And now they say, okay, most people in the town, right, bank with one or both of this bank. Now, if I were to ask you, what kind of an event is this? This would be a mutually inclusive event. Why is that? It's because one out of these 1.5 people, right, some of them can bank with one of these banks or both of them, right, making this kind of event a mutually inclusive event. Right. Now, they said, okay, 600 people bank with Ed Savings. So Ed Savings in total, it has 600 people. And remember, these people include those people who bank with both Ed Savings as well as Multiplier Bank, right? This doesn't mean that the 600 people bank with Ed Savings only. No, it includes those people who also bank with Multiplier Bank. So same applies with your multiplier, right? So your Multiplier Bank has 950 people, and these 950 people, some of them bank with Ed Savings. All right. Now, 235 people in the town do not use either Ed Savings or Multiplier Bank. Now, this is very important. So let me just write it here. So here, the probability of people not banking with Ed Savings, I'm going to represent it with the letter A, as well as Multiplier Bank, I'm going to represent it with the letter M. And this simply means that excluding, so the probability of people who do not bank with both of these banks, not the probability rather, but then the number of people who do not bank with both these banks are 235. Do not bank with both of them. So now, making use of this information, we need to try and draw a Venn diagram. Let me go about doing that. So, right. So now remember, I said the two events are mutually inclusive. So this represents Ed Savings, and this represents Multiplier Bank. Right. And now they said how many people do not bank with either of these two banks? 235 people. So this is my sample space. I'm going to write it here. 235 don't bank with either banks. And now I need to try and draw a Venn diagram for this. Now remember I said the 600, right, includes the people who, the 600 for Ed Savings include the people who bank with also multi-bank, and same applies with your multi-bank 950. It includes some of the people who bank with Ed Savings. So meaning that the probability of both banks, let me represent it in terms of X. So to find the probability of Ed Savings only, right, so we would need to take the 600, right, and subtract X. Why am I doing this? I'm going to make use of the similar formula I used before. Now, in this case, the probability of event A only plus the probability of event B only, right? Plus the probability of both A and B happening, plus the probability of A or B not happening. In this case, this should be equals to the total number of people, which is 1,500. And by the way, this is not these values do not represent probabilities, but then they represent number of people, right? So this P values, or rather this P alphabets, I'm just putting them here for the purpose of understanding. All right. So remember, this represents the number of people, not the probabilities in this case. Now, the probability of people having Ed Savings only, I said it's going to be, because I said probability of both these banks or people banking with both these banks, we're going to represent it as X. So the probability of people banking with Ed Savings only is going to be 600 minus X. And the probability of people banking with if, multiplier bank only is going to be the 950 minus X. And as we said, the probability of both events, right, or both people or people banking with both banks, we're going to indicate it with X. And the probability of people banking with neither of these banks is going to be 235. And as I said, this should be equals to 1,500 people, which is the total population we are given. All right. Now, let us solve for our value of X, which is the probability of people banking with both these banks, and as a result, this would enable us to calculate the probability of edge savings only, or rather the number of people banking with edge savings only, as well as the number of people banking with multiplier bank only. So now here, right, this negative x is going to cancel out with this positive x. As a result, I would be left with 600 plus, I'm grouping like terms, 950 plus 235. And here I have my minus x remaining, which I'm going to put here. And the other side, I still have 1,500 people. And now solving for my x, which is the probability of both or people banking with both banks, right? So now the number of people banking with both banks, multiplier banks, as well as at savings bank, which is indicated by x, right? I'm just gonna try and calculate it, and that value I'm gonna put it here, right? So when I punch this into my calculator, so I'm gonna take the x to the other side. I'm gonna take the 1.5 this side. So 600 plus 950 plus 235 minus 1.5. This should be equals to x, which is the probability of people, or rather the number of people banking with both banks. So now 600 plus 950 plus 235 minus 1.5. Our x, people who bank with both banks, are 285. These are the number of people who are banking with edge savings as well as multiplier bank. And as I've said, that value we would need to put it there in the middle, right? So let me just erase here. So here it's 285. Now, let me calculate the probability, or rather the number of people banking with edge savings only. So as I've said here, it will be 600 minus my x, which is 285. So 600 minus 285, 315 people bank with edge savings. Now I need to do the same for my multiplier bank. So it's 900 minus my 285. And this is 615 people. And as I've said, when you add all these values, they should be equals to this 1,500. And this is our complete Venn diagram using the given information with regards to the two banks, right? So let me just erase here so that we could answer the preceding questions. Now, what is the probability that a person from the town uses both banks? So how would we go about doing this? Now, remember the formula of your probability. It is the option that you are looking for over the total number of options. Or if you want to make this in terms of people, it is the number of people you're looking for, or a certain group you're looking for, over the total groups, right? Or total number of groups. So for this case, the probability of people using both banks, how many people are using both banks, is 285. How many people do we have in total? We have 1,500 people. Now, we can calculate our probability, which is 285 divided by 1,500. And the probability of people using both banks, it will be 0.19. Right. Now, what is the probability that a person from the town does not use multiplier bank? Now, this is important. It simply means that this person, right? So basically, this person either uses edge savings bank or does not bank at all, right? So how many people are using edge savings only? There are 315. And how many people who are not banking with either of these banks? There are 235, right? And these are the number of people basically who are not using multiplier bank. And the total number of people we have is 1,500. Now, punching this into your calculator should give you the probability that you're looking for, 315 plus 235 divided by 1.5. And our probability is 0.37, rounding it off to 2 decimal places. Right. That would be all for this video. Remember, if ever you have any questions, always feel free to reach out. Thanks.